So this is a problem I saw on the internet, right? And like, okay, this is like a retake. Yeah, I'm being completely honest because like I spent way too much time in the last video and I didn't look at the question properly. Anyways, yeah, I will tell you why this is a retake. Anyways, so this is going to be improvised, but it was too long to be improvised. So yeah, I'm re-recording it. Anyways, so yeah, this is actually, it looks easy, but it isn't as easy as it looks, right? So the original question said that we have to find f of 2022, right? But I'm not going to because I like complete solutions rather than just like a single value. This sounds really bad. Anyways, x plus y and then okay, so we have all that stuff, right? So the first instinct with any functional equation really is to plug in x equals y equals 0. So from here you can do some manipulations and you see that f of 0 is equal to 0, right? Now, okay, so this is like a really trivial thing you do, right? You do this basically every time you solve a functional equation. Anyways, now let's do this one, right? This is also something to do sometimes. So what you want to do is like you want to get special values inside these things, right? So we do this first. So we get f of 0, which is 0. We know that 0 is equal to f of x. I'm gonna do that backwards, right? Y equal to minus x, and x is free. X free. Anyways, that's gonna be minus x. And no, that's gonna be minus x square. Yeah. So from here you get an identity that is f of x plus f of minus x is equal to x square. Okay, that's cool. Okay, that's something, right? So from here, if you notice some stuff, we've been given an initial value for it, right? So using that, we could find like a single solution to this. No, wait, what was I saying? Yeah, I was saying that we could find a solution to this problem if you use this, right? So we could get like f of minus 4 is something and all that stuff, but that's not something we need. We need like positive values and stuff because actually we want to solve for x in general. So now we do another substitution. Y is equal to 2x, right? Into the original equation it goes, oh wait, not 2x, actually x. Yeah, so we get that f of 2x, right? So x plus x, that's 2x by the definition of multiplication. If you have two apples, then you have two apples. That's such a shit analogy, dude. So that becomes 2f of x because like y is equal to x, so f of y is equal to f of x plus x xy, but x is equal to y, so that's going to be x squared. Yeah, x squared. Okay. Yeah, so if you take notice from here, we can find f of 2 and then from that we can find f of 1. So let's do that, right, for the chills. I don't know. So let's set x equals 2 in this equation. So we get at f of 4, which is 10 by our given here, is equal to 2 times f of x, just 2 times f of 2 in this case, plus 2 squared, which is 4. So simplify this and you'll get that f of 2 is equal to, so it's going to be 3. Yeah, there you go. F of 2 is equal to 3. That's great. F of 2 is equal to 3. Then yeah, so interruptions. Anyways, f of 2 is equal to 3, right? We found that. Now we can again plug in say x equal to 1, right? So we get f of 2 on the left hand side, which is equal to 3. We just found that out. And then that becomes 2 f of 1 plus, well, it's 2 squared. That's no wait, that's 1 squared, actually 1. Yeah, so that makes more sense. 2. So simplify this a bit and you get f of 1 is equal to 1. Okay, so far so good, right? And of course I'm doing this like because I've done this before. If you were doing this like on your own for the first time, you'd probably take some more time. Anyways, so yeah, I know what to do next, right? But you'd have to play around with the equations a bit. So you'll play around a bit and you'll realize that plug this into here, right? We're gonna, so notice that I've said f goes from the integers to the integers, no positive or negative stuff, so both count, right? Or this wouldn't make sense, anyways. So so plug in x equal to 1 in this equation, right? X equal to 1, so this becomes f of 1, which is 1, plus f of minus 1 is equal to 1. Yeah, so f of minus 1 is equal to 0. Now these are two conditions we have, right? These are the two most important ones. I'm actually going to rub off these boxes, because like these are not going to be that important from now on, because we're going to be doing like actual stuff, and these are just like side steps to it, but these two are like really important. Anyway, so the next thing you do is you notice that so for x greater than or equal to 2, f of x is equal to 1 actually, right? Yeah, 1. F of x is greater than or equal to 1, because you see these are just additive and these are both going to be positive, so you're going to add up to 3 and then you put a 1 into the 3, so it's just going to keep adding up, and so any x values that's bigger than or equal to 1, they're going to be bigger than 1 basically. If that's equal to 1, then it's going to be equal to 1. Yeah, anyway, so that's for the positive case. Now again, as I said, you're gonna have to play around with this a bit if you like doing this on your own for the first time, so don't feel like I'm a god or something. No, I also took a lot of time for it. Anyways, yeah, so that's one condition, right? And then what you have is, okay, so right, so f of minus 1, right? So let's study the negative case a bit more. So let's plug in x equal 2 into this equation. So this equation gives us, with x equals 2, it gives us f of 2, which is 3, we know that, plus f of minus 2 is equal to, 2 squared, that's 4. So f of minus 2 is equal to 1. That's one thing. Yeah. And now you could of course go on adding this stuff and you'll get the same thing. So basically for x less than or equal to negative 2, f of x is now greater than f of x would then be so for x less than or equal to minus 2, f of x would be greater than or equal to 1. And of course you may doubt this because it's negative. Of course it's gonna be negative and it's gonna go into negatives or something. I don't know how people talk. Yeah, so you may say that, but then again notice that these both x and y are going to be negative, right? When we're calculating the negative numbers, and these are positive because this is 0 and this is 1, so it's strictly like greater than or equal to 0. Anyways, well, I guess not positive, the positive including 0, call it that. Yes, basically this whole thing can never be less than 1 for x less than or equal to 2. So basically, if you noticed, this is only for the integers, right? So say f of x has roots alpha 1, alpha 2, all the way to alpha n, right? Say it has n roots, because no one cares, why not? Yeah. So we're going to suppose that it has integer roots, and in this case it works out, right? Because it's going for the integers to the integers. If it had like non-integral roots, then there'd be some sort of discrepancies within the solutions, right? Because then it wouldn't go from the integers to the integers. Anyways, yeah, that's a long explanation for a rather short concept. So say these are the roots, right? Alpha I are the roots, right? And by roots I mean like f of alpha I is always equal to 0, right? So what we notice is that alpha I always lies between, so it cannot be equal to negative 2, right? So it can not be equal to it, It can't be equal to 1 either. So 1. Well, notice that for integers, the only values that are left for this are -1 and 0. That's two roots. We have alpha 1 equals -1, alpha 2 equals 0. Again, it doesn't matter which ones have which, because it's like interchangeable if you know anything about roots of an equation, or of a polynomial in this case, but yeah, same thing. Anyways, so those are the only two roots, right? The only two integer roots. And again, if there were any non-integral roots, then you'd have like weird stuff happening, like f not going from the integers to the integers, you know. Anyways, so we use these conditions and we form an f. So notice that if it only has two roots, then f has to be, again, either f has like repeated roots, which is rather weird, but okay, I'll allow it, right? But the simplest case in this condition, yeah, I guess it could have repeated roots, and we'll consider that, right? Anyways, yeah, let's only consider the simplest case, right? So it has to have at least two roots, so f has to have a degree of at least 2, right? So say f of x is equal to ax squared plus bx plus c, right? So we plug in 0 into here and we know that's going to be 0. So 0 is equal to so it's going to be like yeah, so we know that x, we've plugged in x equal to 0 and f of 0 is 0, we know that, right? So this is going to be 0, this is going to be 0, so c is equal to 0, we know that now. And then we plug in x equal to -1, we get that a minus b plus c, but c should not exist now because it's 0, so bye bye. But f of -1 is also 0, right? We found that out here. Yeah, so f of -1 is 0, so a is equal to b. We found that f of x is equal to ax x plus 1, ax times x plus 1. The only thing left for us to find is what is a, right? So and that is not that tough, I don't think it is. Anyways, so we plug in x equal to 1, right? And we're doing that because we have some initial values, right? So f of 1, which is 1, I am not going to waste much time now. 1 is equal to, so a times 1, that's a, and then times x plus 1, that's 1 plus 1, which is 2. So a is equal to 1 by 2. And why is this not done? Why am I so tilted? Okay, so yeah, f of 1 is equal to a times 2, right? A of, that's not a of 2, actually, that's like a times 2, just in case you're confused. A is a constant, it's not a function. Anyway, so f of 1 is equal to 1, so that's how we know that a is equal to 1 upon 2, or 1 by 2, or half, or I don't know, people call it many things. So basically we have our equation, right? F of x is equal to half x square plus half x. Notice that this is a common denominator, so it's just going to be x squared plus x upon 2. So that's going to be x times x plus 1 upon 2, f of x. And what we've stumbled upon is something that's, it's rare to find, I think. Maybe it isn't, I don't know, maybe it's like really common. that may be the possibility. Anyways, what I found is the formula for n natural numbers, right? You can prove this inductively or any other method, but you basically see it, right? Because f of 2 is equal to 3, f of 1 is equal to 1. So 1 plus 1, 1 plus 0 is 1, 1 plus 2 is 3. If you want to find f of 3, you're going to find that it's going to be 1 plus 2 plus 3, that's 6. Yeah, that's going to be 3, and then plus 1 plus 2 times 1, that's 2. 3 plus 1 is 4, plus 2, that's 6. Again, as I said, that's a really well constructed problem. That's why I like it a lot, right? Anyways, so Yeah, from here you can of course easily find f of 2022, but that's not the point, right? Solving the problem is not the point. It's the way you solve the problem that matters. Now I'm gonna rub off this stuff because it was kind of useless. Kind of is useless actually, not was. So now we suppose that it has like more than two roots. I just thought of that for some reason. Yeah, I didn't have the brains to, comprehend that. So um, say it's a cubic now, right? So you have like f of x is equal to, well, now I'm just gonna use the formula, so to speak, for like cubes. Anyways, yeah. So it's like the first term is just x cubed, and the second term is like minus the sum of all the roots. It's gonna be x cubed minus. So that's gonna be two zeros first. Right? Call this f1 of x. I don't know why not. So it's gonna be two zeros for here. So this remains the same, right? Minus 1 plus 0 is going to be plus 1x squared, right? And then plus the two-way product of the roots. So minus 1 times 0, 0 times 0, and then the sum of the two-way product of the roots. Hopefully Vieta's formulas. I'm not going to revise those. These are like very easy to derive. Anyways, and they're like very commonly known too, right? Anyways, yeah, 0 times minus 1, 0 times 0, minus 1 times 0, that's just going to be 0. So that's 0x and minus some constant, right? And the constant is just the multiplication of this, that's minus 0. It's going to be x cubed plus x squared. Yep, literally. It's going to be x squared times x plus 1. That's f1 of x. Now let's see, is this problematic at all? Because these two functions are very obviously not equal to each other. That's wow. How the hell? Yeah, anyways, so let's see, is there a problem with this? Right, so let's start plugging in 4, right? So 4, it's 4 squared, that's 16, and 4 plus 1. Okay, so maybe I made a mistake somewhere. I don't know. Kind of like doubting myself at this point. That's like most of my life actually. Anyways, it's gonna be x cubed, then minus s x squared, I'm gonna call it that, plus p1x minus p2, right? So we just found out that this is going to be 0, so we don't need the indices for p at all in the first place. Then the sum of all the roots, but that's going to be minus 1 times 0 times 0, it's going to be minus 1, so that's going to be so this whole thing is going to turn into plus a 1, yeah. And then the product, the two-way product of the roots, minus 1 times 0, 0 times 0, and minus 1 times 0. Yeah, this is going to be 0. So what we get is x squared times x plus 1. And that does not work out for our equation. Why is that, you may ask? Well, yeah, I don't know. That's interesting actually. Anyways, yeah, that's pretty cool though, right? At the end of the day, if you want to calculate this, you will get the solution as like 1011 times 2023, and that includes the 23, and that's why it's nice, right? But point being that we need like why can't there be repeated roots? That's what I ask. So oh, but repeated roots wouldn't make sense. Yeah, why the hell would you want repeated roots? You're on the simplest polynomial, right? That's one way to think about it, but that's no good way to think about it. Anyways, this is a big question mark. That's cool. Yep. Nice. Yeah, nice. Actually nice.